Hello students, last time we have started the cardinal points of an optical system. There are 6 cardinal points here, out of which we have seen the 2 focal points, F1 and the F2. 2 focal points, we have seen the definition of this. Now we will see the another definition today, that is H1 and H2, 2 principal points H1 and H2. And next after we will see the N1 and N2, that is the 2 nodal points of an optical system. So there are 6 cardinal points of an optical system, 2 focal points, 2 principal points and the 2 nodal points. Now today we will see the principal points and the principal planes, that is indicated by the symbols H1 and H2. So this is the optical system, and the line which divides the optical system into 2 parts is known as the principal axis or the axis. Now last time we have seen the all 6 cardinal points lies on the principal axis here. So in this figure, the first of all we will consider the ray AB parallel to the what here, the axis, parallel to the axis. After refraction it passes to the point what we call as, according to definition, the second focal point of an optical system, because second focal point is a point on the axis such that any ray of light parallel to the axis passes to it after reflection. So this is the second focal point, which is indicated by the single arrow here. So this ray is represented by the single arrow. Now here, when the emergent ray or the refracted ray CF2 produced back at the incident ray AB is produced back, then they meet at the point E2 here. Now draw the line passing through the E2 and perpendicular to the axis like this. Then this E2 H2 is called as E2 H2 is called as the second principal plane. Second principal plane. Principal plane. It is called as second principal plane, and its point of intersection with the principal axis gives the position of what here, the second principal point, that is nothing but S2. So the second definition of the second focal point leads to the definition of what here, the second principal point, that is S2. F2 tends to, from F2 we can estimate the S2. Now consider here the ray of light passing through the first focal point, that is nothing but F1. According to definition of the F1, after refraction it proceeds parallel to the axis. This proceeds parallel to the axis. So EG is nothing but what here, the emergent ray, and its incident ray is nothing but F1T here. When this emergent ray EG produced back and its incident ray, that is F1D, produced back, then they meet at A1 here. So then they meet at what here, the A1. Now draw the line perpendicular, draw the plane perpendicular to the axis and passing through this A1. A1 is called as, that is A1 H1. A1 H1 is called as what here, the first principal plane. First principal plane. It is called as first principal plane here. And its point of intersection with the axis, that is nothing but H1, gives rise to here the first principal point, that is H1. So we can define these are the points, H1, H2 principal points are the points on the axis such that the optical system has lateral magnification. It has the lateral magnification, unit magnification, lateral magnification is equal to 1, or the unit positive lateral magnification. So these are the H1, H2 are lateral magnification can be defined as here lateral magnification, LM say it is defined as height of image divided by ratio the height of object. So here in this case we are getting here So this will be equal to, if suppose here, in other words, so H1, H2 are the principal points on the axis such that here the lens system, optical system has unique positive lateral magnification. In other words, these are the points on the axis such that if the object is placed at one principal point, its image of the same size is obtained on the other principal point. So if suppose the A1 H1 is nothing but the object, then its image we are getting at S2 E2 S2, means here if suppose y is nothing but the height of object, here y1 is nothing but height of object, suppose A1 H1, y1 is height of object, y2 is nothing but what here, the height of the image, and these are equals, and therefore this will be equal to y2 divided by the y1. So this will be equal to plus 1 in this case, because y1 is equal to y2. So these are such a points are called as the principal points. So how principal points can be located? So by considering the ray of light EB parallel to the axis, after reflection it passes through the second focal point F2 of the optical system. When this emergent ray or the refracted ray CF2 produced back and its incident ray EB produced back, then they meet at E2 and draw the perpendicular plane passing through the E2 and perpendicular to the axis is called a second principal plane, and its point of intersection S2 gives the position of the second principal point, that is S2. And first principal point related to the first focal point. So consider the ray which is indicated by the double arrow here. So F1D we have considered the second ray which is passing through the first focal point, and according to definition, after refraction it proceeds parallel to the axis, that is the refracted ray which is parallel to the axis. When this emergent ray and its incident ray produced back, then they meet at A1 and draw the line perpendicular or plane perpendicular to the axis and passing through the A1 is called as first principal plane, and its point of intersection, that is H1 on the axis, gives the position of the first principal plane, that is H1. So these are the points. So how it can be defined? H1, H2 are the points on the axis such that the lens system has positive unilateral magnification. This is because, in other words, here we can also be defined the principal points are those points for which if the object is placed at one principal point, here to here, then its image of the same size and shape is obtained on the other principal point. So height of the object and image is same. So we are getting lateral magnification is equal to plus 1 here. So these are the two definitions here. So from this it is seen that here, from this figure, if any ray of light is directed towards A1 here, EB it is directed towards A1. If suppose this lens system is not present here, suppose, and these two rays are directed towards the A1, they will be emerges out from the point E2 here, and therefore the E2 will be the image of A1. So therefore, if the object is placed here, the image point we are getting here. So, and of the same size, so the lens system has positive lateral magnification. Also, we are knowing that when in case of the single lens, if the single lens is considered here, and if suppose this is the axis, any parallel ray here passes through the point is called as the second focal point, that is F2. Here, any parallel ray passes through this point is known as the F2, and this distance is known as the focal length of this lens system. This distance from lens to this sharp point, any ray passes through this here, all these rays are passes through this, and therefore this we are getting the concentrated point here, and this distance from the lens to this F2 is known as the F2, second focal length of the lens system. So this is in case of the thin lens or the single lens, but when this lens is thick lens, we will take into account the thickness of the lens here. And here you have to remember that what is the focal length of the lens system. So for that, remember that this distance of the first focal point from the first principal point, that is the distance h1 f1. This distance h1 and the f1 is called as the first focal length of the lens system, that is f1, and distance of the second focal point from the second principal point, that is h2 f2. This h2 f2 is known as the second focal length of the lens system. So in case of the optical system, the distances of the focal points here, or the distance of the image is measured from the h1 and the h2. So remember that in case of the optical system, we will measure the distances not from here. If suppose object is placed somewhere like this here, so the distance of this object can be measured from this h1 here, from this h1, and not from this point, just like in case of the thin lens here. And also the distance of the image, for example, we are getting somewhere like this, so this distance can be measured. Distance of the image can be measured from the h2. It can be regarded as v, it can be regarded as u, as usual, and so on. So how these parameters are related, we will see in the next article. To see the relationship between this is f1, f2, or f and f dash. It can be regarded as f and if suppose f dash. So we have to find out the relationship between f and f dash. How it can be find out, we will derive in the next lecture. But before going to that, we will see the node, what are the nodal points and the nodal planes in the next article. Also you have to remember that the optical system can be represented by the focal, here the principal points, instead of this curve. If suppose this is the principal axis, here the axis which separate the optical system into two parts here, and if suppose this is the principal points, it is represented by the h1. This is here the another is nothing but the h2. h2 is represented like this here. So instead of this, we can represent the optical system in this way and so. So this is the plane, the first principal plane, this is the second principal plane, and also you have to remember that here. So any ray directed towards here, so you have to see here, directed towards here, falls. This ray falls on this, its emergent ray will be proceed from the same height here. Here is also, it is passing through the same height. Suppose if any ray is passed through this here like this, is incident at this distance, its emergent ray will be proceed from this point. Similarly here, if suppose the incident ray is incident for this like this, its emergent ray will be goes from like this here at the same height. The emergent ray, double arrow I will draw here for the distinguish between these two rays. So if this ray, if suppose the another ray is incident like this height, like this height, third ray here, third ray, then its emergent ray will be proceed from the same height. This is one of the important property of this plane, and these properties can be useful in case of the further articles which we should know. So what you have to know is that this distance h1 f1 is known as the first focal length of the lens system, that is f1, and this distance f2 up to this can be regarded as the second focal length of the lens system. And any ray directed on the first principal plane, it will emerges out from the second principal plane at the same height. So these two properties you should remember for the further articles. Okay, thank you very much.